Welcome to solverfy.
Explain why Newton's method fails to find the roots of the equation f of x equals 0, where f of x is x cubed minus 3x plus 6 if we use the initial approximation x1 is equal to 1. To answer this question, we should recall what Newton's method means geometrically. So let me just draw the graph of a function. And suppose that we want to find an approximation to this root here. What we would do is just choose a nearby point on the x-axis and draw the tangent line to the graph of our function at that point. Now what we would do is see where the tangent line intersects the x-axis again, and we'll use that as our next approximation, and we'll keep repeating this process until we are as close to the root as we like. So now if you write down the equation for this tangent line and see where it intersects the x-axis, you can find the formula for the next approximation for Newton's method. So the way we get our next approximation is we take our current approximation, x sub n, and we subtract f of x sub n divided by f prime of x sub n. So to use this formula, say we want to find the next approximation, we would have to find the derivative. So let's compute the derivative. If we use the power rule, we get that the derivative is 3x squared minus 3. Alright, and now let's see what would happen. To find x sub 2, we would need to compute f prime of x sub 1. So let's do that. We're given that the initial approximation is 1. And now if we plug that into f prime, we just get 3 minus 3, which is 0. Okay, and now we see where the problem is. We're not able to find the next approximation because dividing by 0 is not defined. So what's happening geometrically? Let's say that here on the x-axis is x1, and now in this situation, since f prime of x1 is 0, we have something that could possibly look like this. The point is that the tangent line at this point has slope 0, so it's horizontal. And that means that it will never cross the x-axis again. So that's why we can't use this point to find the next approximation for Newton's method.